Okay. So let us start with the full pivoting. If you remember, what we had in this full pivoting is, this is an example of this full pivoting. So some example problem we had with the full pivoting. What we did is, we first see all the elements, we see the whole matrix as a whole, okay, and then we will see which is the maximum magnitude element here. This is the maximum magnitude element. That element should be pushed to the diagonal element and then make this one 0. And then look for the submatrix here. Again look for the maximum magnitude element, that is 10. Push it to diagonal, push it to the diagonal element and make it to 0. Okay, this is what we have done in the we saw the full pivoting. So I will show you a demo code in which I have implemented this full pivoting. For people who are done also, you can just have a look at it. So I have not yet checked your codes. So okay, so I will do that, and fine. So here is the code. Yeah. So I have picked up the same. This one, the matrix what we have. If you see here 1, 2, 3, 4, 5. It is a 5 cross 5 matrix, but there are 6 columns because the last column is B. And this is a program. Fortran code. It is a very simple code which can perform a pivoting also, full pivoting. Okay, so this is the line. Can you people see the screen?
Yes, sir.
Okay, fine. So should I, this is visible, or should I want to make a dark background, or white is better?
Sir, it's visible, but dark is better.
Dark is better. Okay, fine. So then let me change the color scheme. That is. Can anyone suggest any color scheme? You are aware about that?
Evening.
Evening, yes. All right, perfect. Correct. So now this is visible better. This is better, huh?
Yes, sir.
Okay, fine. So you can see this is the program and this is the input file. You can see the name input here. This is input file. It reads, and again the same code. It asks for the dimension. I am reading the code. Let me print the matrix and I will stop here and let us see whether it prints properly or not. Okay, so I am going to the
Sir, what does keyword stop do?
STOP.
Like, what's its function? Like, it exits the program there?
Yes, it exits the program. It simply exits the program.
Same as call exit. Then.
Call exit is exit the loop. Stop will stop the program. It completely stops the program and come out of it. It won't perform any further steps.
Okay.
Okay. Exit will just exit the loop. Okay. So yeah. So now here this is the code. So let me try to compile. So Gauss elim, I guess pivot. This is a name, right? Gauss elim pivot.f. You can see the name here. Okay. So this is the code I am running. Fine. So well, and out. Okay, let us take again for a case simple matrix, 4 cross 4 matrix. Even though I given 5 cross 5, we can take 4. Doesn't matter. It doesn't bother about what other elements we are given. Okay, so you can see this is a nice good matrix I have given. Okay. So and okay, I have written in this particular form. Anyway, it's okay. This is a childish way of writing, but doesn't matter. Okay, it's printing this file matrix here. It's a 4 cross 4 matrix, and this is your B matrix. Okay, this is a B matrix we are having here. So now let me see what is the next line in the code. Fine, and I'm removing this top, and now you see I am making this upper triangulation. Okay, so before it goes to upper triangulation, I will close this input file. We know that input file now it's there. So before it goes to upper triangulation, I have created a subroutine with the name pivoting. So this is the subroutine which creates the which performs a full pivoting. Okay. Before that, I forgot to mention you. As I read this is the way I am reading. Okay. So A of I comma j, I am reading row by row. and I read the 5 elements of the row and then the B matrix. Sorry, 4, we get 4. 4 elements of the row and B matrix, and 4 elements, you do that. So, and this line is interesting. See what happened, if you remember in full pivot, we are going to perform your column operation also. Am I right? So any row operation will swap the vector B, but any column operation will swap your unknown vector X, and we don't provide the X. Okay, but on the other hand, now since we are swapping the column, so when I swap the columns and finally get a result, all my X, Y, Z, they are all jumbled. Okay, x1, x2, if I have 4 cross matrix, x1, x2, x3, x4, when I get the final solution vector, I won't get in the same form of x1, x2, x3, x4. Because of all this column manipulation, my x vector is completely jumbled. Am I making it clear, everyone? Respond?
Yes, sir. Yes.
Okay, fine. So now since I have to take care of my whatever the column manipulation, I need to have though I am not giving the x vector, I will give the index. This is x1. So this row corresponds to x1, this row corresponds to x2, this row corresponds to x3. So for that I am adding an index array, integer array. You got it? I have not made it as a real array, I have made it as an integer array because it is just an index. There is no need for me to go for a real array. So I have defined an index array, and what it is, ix of I. So will be equal to I. So in this, after this loop, what happened? X of 1 equal to 1. Pardon?
Sir, why is it written as? Okay.
You got it? Yeah. So in this loop, after this loop, what happened? Ix of 1 is 1, ix of 2 is 2, ix of 3 is 3. Ix of 4 is 4. Okay, so this is the one which really going to take care of my jumbling of my shuffling of my X elements. Okay, so this is one thing I have to read it. I have to keep it up. So, and this is required because of the column swapping we are doing. Fine. So now, we print the matrix. It was printing very well. Yes, coming back to triangulation. So before going into the triangulation, so this is the same loop. I am not going into the loop. Last time we discussed how this upper triangular matrix is being performed. So if you want, I think one class I showed the code also. Okay. So let us go see what is this pivoting subroutine is doing. Okay, so I will open it like this here. So we are going to the pivoting. Fine. So let us see here. This is the same code. I'm opening in a. Okay, fine. So this is the one. So the pivoting. So what happened? What are the input for the pivot? Matrix A, matrix B, dimension of the matrix, and the I. You got it? And this I is essential. Remember why I is essential is, if you see here, when I am going for the pivoting for the whole matrix, I see the whole matrix means all the matrix, right? N cross N matrix. After making this element 0, then I will go for the smaller matrix. So the dimension of the matrix keep decreasing by 1. So that's why I kept here, I am passing here I also. Okay. So now let us see how I am handling it here. So this is the A, B, N, and that I am reading as a K, and this is the index of X I am taking up. Okay, so then first I have to locating the biggest magnitude element. What am I doing? I am defining a variable named big equal to 0. I know always the magnitude element is going to be greater than big. So then I search the entire matrix. You remember these are two loops, but I am starting from K. This is important part. Why K? Because the K is the one passes the I here. When it passes 1, it searches for the whole matrix, 1 to N. On the other hand, when I come to the when the loop comes to the next one, it becomes 2, it starts from 2 to N. You got it? So that's the way I am implementing this, first searching for the whole matrix, and then after making this element 0, then when I go for the next element, that is the next I equal to 2, then I will look for only this part, 2 to n, 2 to 3 here in this example. Okay, so and in this way, in that matrix, I scan the whole, all the element, and I see which any element which is bigger than my big. Okay, I started with big, so equal to 0, so and then I keep replacing it. Then big is that particular element, and now I mark the column and the row of the element, the highest magnitude element. Okay, so this is a very simple part. When it comes out of the loop, what it says is it knows what is the biggest magnitude element as well as which row and column that element belongs to. So this one I have. So now what if you see, so now I identified this is the one. Okay, so then what I have to do, I have to bring that to the diagonal element. So what am I doing? So here we have a row manipulation only. So suppose if it is here, then I have to do a column manipulation. So I know, so the index of this element is also known to me. Okay, so so now I have to do the swapping. First I am doing the row swapping. So row swapping is trivial. Okay, so I am going to just swap the row. When I swap the rows, all I have to do is I have to swap the B vector. When I swap the row, I have to swap all the elements of A. A in the second row goes to first row and the first becomes second. And that's what I am doing here. Okay, first I am going to swap B. I am swapping the B here. So what am I doing? I am taking, say for example, yes, the K. Remember, the K is the one we are always switching to the first element. Okay, this is the diagonal we are going. So it belongs to row 1. And the row 1 is nothing but our K. We pass the K. So I put this K in at some temporary variable, and then that is here, right? This variable I put it in some temporary variable, and then I replace this variable with this variable. That's what I have done. I row. Here I am taking it 2 because this is the highest magnitude element. Here it will automatically pick up because I have actually modified. I have noted which is the row has a maximum magnitude element. It swaps it. So this 3 line just swaps the B vector. So and similarly we have to swap the A matrix. For A matrix is not the only element. So you have to do all the elements. So I need a loop for that. It is the same thing when I am doing it for all the elements. Okay, you can combine this also along with it, and you can read it as a whole matrix, a single matrix of with a column with +1, and you can do that way also. That's also allowed. Okay, I put it for simple so it will be easy to understand. Okay.
Sir, for finding the location of maximum element, there is an inbuilt function in Fortran.
Correct. Yeah, I got it. Because in a Fortran 90, there are many options you have. There are many inbuilt functions which can find a maximum magnitude element and all. As I told you, I stick to Fortran 77. Okay, this is the way I do it out. Okay, and in fact, sometimes I never feel. I never understand why I need to have a function for that. It is just a 4-5 lines for me. Okay. So you can do it out like that, but anyway, that's okay, not an issue. But remember, the problem will be when you want to look for the submatrix, and you have to declare the submatrix as a separate matrix and use it from the biggest magnitude element from there. Maybe in Fortran 90 they may be having a provisions, but in Fortran 70 I handle it in a very easy way like this. Okay, am I making it clear? Clear, everyone?
Yes, sir.
Okay. So means max people are also able to follow me, right?
Yes, sir.
Okay, so if you have any doubt, you ask me, I can repeat it also. Okay, so this row swapping is simple. So this row swapping I have performed. See, in the row, I don't have to really bother about my X at all. So here it is, I am very safe. I just swapped my B vector and my the rows of the A matrix. That's all I have done. This is done for me. Now coming to the column swapping, because I have noted the column also, the biggest magnitude element, the column of the biggest magnitude element. Now I have to swap the columns. Now when I swap the columns, my B won't be changed. B won't be altered. Only my X vector will be altered. So now since we don't have the x vector, we are performing the same operation with the index. Okay. So what I have done, see here I define itemp, and itemp is an integer. You got it? I don't have the value, I have the index. I define an item and I take, this is a k, okay, because basically again in the column also we always try to make it for the first diagonal element, then second diagonal element, so it will be 1, right? So when the column k comes out 1, so it takes the index of the vector. Remember, ix of 1 is taken as an item, some value, and then I am replacing that ix1 with the maximum, the index. I am replacing the ix1 is the index of the maximum column element. You got it? Maximum column, yeah, the element, maximum element falling in which column? That's what I am replacing it. And then I switch back my I call to this, is how I am swapping it. Can you people understand this line? Anyone? Or not clear?
So it's clear.
It's clear. Perfect. Good. So if you are not clear, just ask me or tell me again, I can do that out. So this is what the operation I have done for the column matrix, and then I have to do the same thing for the same thing. What is this? A column swapping for the A. Okay. Again the same way. What I did this way, I can do it here very easily. The same way, but I am going to just the index will change. See here is k by I. Here will be I by k. Okay. So this way I can swap the columns also. So this operation, the entire operation, what we have done here, this has eventually moved my maximum magnitude element to the first diagonal element, that is A of kk. Got it? And since we are passing it as a 1, if the k becomes 1, this maximum magnitude element is pushed to A of 1 1. Okay? And then I am returning it. So now remember, now what happened, this ix, when you passed ix of 1 equal to 1, ix of 2 equal to 2, ix of 3 equal to 3, ix of 4 equal to 4. But after this operation, you are not going to get the same thing. Okay, the ix of 1 will not be 1. This actually ix of 1 is already swapped with the biggest magnitude, that particular column. Okay, so that number gives you indication. So when you get back the solution, the first solution doesn't belong to x1, it belongs to the index of this ix1. Got it? So, and then when I call back, so this is what? So then I have this, after this pivoting, I have done all this jugglery with rows and columns, and then, okay, good, I'm printing it here also. So let us make a pause, stop here, and let me print it. Let us see what it does. Okay? So this will be a good one to see. Fine. So let us see how, let us see whether it's doing correct or wrong. Fine. Okay. Now, you see. Okay, let us give the same 4. So you can see here. What is the maximum magnitude element? Yeah. See here, this is a slightly I have modified the matrix. So I have given a maximum, if you see this is the matrix, the maximum magnitude element is 30, minus 30, correct? So the minus 30 is brought here. Okay? So you can see all the columns and everything accordingly swapped. And the rows were also swapped. Is that clear, everyone? And your x vector, your b vector is also swapped because there is a manipulation, row manipulation is performed. Okay? Clear? So this is completely, I should have written the x also, but anyway, that's okay. It doesn't matter, you can print later on. You can do it that way also. Okay? So then this is so now you can see the first, and this is a diagonal element. So this is a pivot element. So you have brought the maximum magnitude pivot element to the first diagonal element, and then you are going to diagonalize, so you're going to make all these elements 0, that you know, that we have to do the row manipulation and we have to do it out. That's what is being done here. Let me remove this top here. Fine. And that's what we are doing it here. And then, okay, I guess, and I have printed that also. Let us print that. Yeah, you got it? Now you see all these elements are 0, so this has made it. Now I have to look for the submatrix, that is this one, correct? this 3 cross 3 matrix. And in this 3 cross 3 matrix, maximum magnet element is 15, I guess. Am I right? Yes, 15. Can you people see the screen? Is it too small or are you able to see it?
You can see it, sir.
Okay, fantastic. Fine. So now we are going to, now this should move to here. Okay, so let us try to print again. So now what happened, I am not going to, I will remove this top. Okay, so then let me run this program fully. Okay, I will remove this top and then I'll put the stop here after the undo. Okay, and now I am going to compile it and I will run it and give me the 4. Okay, now you see. So this is where the maximum magnet element is pushed to first diagonal. Then all these columns made to 0. Then this is a submatrix it is checking. Maximum magnet is 15.667 and that is pushed to the next diagonal element. And the next approach this makes to 0. Okay, and now if you see here, the maximum magnet element is 7.638. That has been moved to the diagonal element and then that made to 0 and you got a very beautiful upper triangular matrix. Is that clear, everyone? Okay, so now let us, okay, now in this whole process our x vector is completely jumbled, but we don't have to worry about it because we had this index, we have stored the index. So let us print the index, this one. So this will give us an idea what are my vectors are jumbled, how my solution vectors are jumbled. So let us print this I vector also. See here, can you people see it? So if you go back and check your whole process, this is the way we have jumbled the one. So though I gave it as x1, x2, x3, x4, after getting this full diagonal upper triangular matrix, so then my solution vectors are shuffled to 4, 3, 2, 1 and 2. You got it? Now I know when I solve this matrix, the first x I am going to get, that doesn't belong to x1, that is x4. Second one is x3, third one is x1 and the fourth one is x2. Okay, so then I know which is the solution vector. Now I have to print it proper form. So that's what I am doing here. So yeah, then the back substitution is done. This back substitution will give me the answer of the solution vector. And now you see here, what I have written, I have defined a new variable x swap of j. Okay, this is a real variable, a real array, x swap of j. This is the swapped vector. That is, this vector corresponds to 4, 3, 2, 1. We have no idea. Now this is the matrix I know what is the index are there. So this solution actually written as 4, 3, 2, 1. But now I have to print it in the form 1, 2, 3, 4. Correct? So, and this swap I got this first value and I know this first value corresponds to this x of ix1 of I. This ix of I is my 4. Okay, so that means that my x of 4 is the x swap of I. It is not x of 1. So this gives me back in a proper form 1, 2, 3, 4. Okay, and then I will print the okay, I'm printing the x swap as well as, okay, the stop is, I remove the stop, right? Yes, perfect. So I'm printing the swap as well as the properly arranged vector. So let us print here, stop here. So I'm stopping here and let us see. 4. Yeah, you can see. So what happened? This is the solution we got. This is of this order, 4, 3, 1 and 2. After swapping, now you see third one should be the first vector. You can see the third is 1 and the last one is 2 and the third 3 and 4. Clear, everyone? Is it clear?
Yes.
Okay, so I am doing a testing also. What am I doing? I am rewinding the data, rewinding the input file, again reading the matrix A and B. I am naming it as a B test. And then what I am going to do, I know my x vectors, right? I got the x vectors. So what I will do, I multiply my x vector with this matrix A and I see whether the solution is exactly matching as a B, the input B. So it's just a test. Okay, so I will do the test also. When you're writing a big matrix program, don't keep this test. This test should be for initially to confirm your problem is working correct or your program is working correct or wrong. Okay, later on when you are doing this, all needs manipulations. It all takes computation time. Okay, so when you make in the later on also when you are making a final code or something, no need to do this testing always. Testing should be done only when you have to really debug the code or something. Okay, and okay, so let me run it, and dimension is 4. Yes, so we got the same answer here. You can see here, testing I written there. So this is the one, all are same. So this is basically 4 cross 4 matrix. And anyway, when I write a code, I always maintain n. I don't give a dimension. Okay, so that the code can be capable of doing for any dimension. So what I do, so let me do for another one. So let me do for 5 cross 5. So dimension is 5 now. Okay, so you can see these are all 5 cross. So now you see these all are zeros. Am I right? These are zeros. Do you agree or not? Anyone disagree with me? This is 0. Correct? Computer says for computer this is a 0. Okay. So now remember, if your matrix elements are all of similar order, then your matrix is your computer will see it as a 0 or whatever, it doesn't matter for it. Okay. So that's why always I caution you, in the matrix never use small numbers or extremely large numbers. Okay, so yeah, it works for 5 cross 5 matrix also, you can see here. Okay, good. Clear everyone?
Yes, sir.
Any doubt you have? Anybody have any doubt? Okay, so it means there's no doubt. Okay, fine. So this is the simple demo to show to have a how a full pivoting is being implemented. In fact, you can do the implicit pivoting also. Just you have to divide that. See, the moment when you do, see what I did is in the pivoting, I showed the program for the pivoting, right? So finally, what happened? You divide all the element with this maximum magnitude element. Okay, and that becomes implicit pivoting. That is trivial, I didn't do it. Okay, you people, if you are interested, you can do that.